So 1017 or 1018 is what you guys have. So let's take a look at that and see what we have here. Okay, we got to download a data set. Okay, so we get that downloaded, and you guys have one as well to download. Okay, and then we gotta do the work, right? We have to find, the things that we need. The x is what's given to us, or the mean of x. There should be a little line over it. Is 1.4. I know that because that's given to me, right? And the n, I know that I've got 10, a sample of 10. Again, it gives me that, so I can enter those things. But then, I've downloaded my data set, and that's that. I do have to calculate my mean. Okay, that's 1.6, so my sample mean is 1.6. Okay, and then I got to calculate my standard deviation, right, of the sample. So I do that in the way that we have done it. That one minus my mean, and oops, I got to put the dollar signs there. Hit the F4. Okay, and then I can just carry that down. Okay, then I can square that to the second power. Okay, and carry that down. Okay, then when I get a total on that remember, normally if we were trying to get the variance, we would just take an average of that. But in this case, when we were doing a sample one, we got to take it, divide our total here by n minus 1, or also the degree of freedom, right? Because that's the same. So I simply did that, so it's equal to that divided by my degrees of freedom, or n minus 1. Okay, and then to find my standard deviation for that, I just take the square root of that. Oops, I don't need the equals. I'm going to go up here instead, and I'll use the square root function. And there we go. Okay, so I know that significance level is given to me, and so then I need to look up my t-value. Right, given that my degrees of freedom are 9, my significance level is 0.01. Degrees of freedom 9, it's a one-tailed test, right, because I got less than or equal to, so I come over here and then down to 9, so I'm right there, 2.821. Okay, and so I'm going to reject if it's greater than this. And again, I'm kind of showing you how to do it using the computer, not necessarily using the fancy stuff. Okay, you guys should state your hypothesis. Okay, so I've got, in this case, it's h sub o. Let's go back and read it. It says that I want 2 on 17. It says, can we conclude that water consumption has increased? Okay, and increased over my population mean of 1.4. So I want to know if in my alternate hypothesis, if mu is greater than 1.4. Okay, so my null hypothesis then is that it's less than or equal to 1.4. So I'm going to reject if it's greater than this. I'm going to reject the null hypothesis and accept the alternate hypothesis, right? Okay, so I do the math, and I won't bore you with the math. I got 1.6 minus 1.4. Right, standard error, the mean down there I've calculated. I divide those, I end up with 2.97. So I reject the null hypothesis, and I accept the alternate is that it is greater than. Okay, and then I go look up the p-value again using my degree of freedoms of 9, and I'm using this number, the 2.9. So I come 9, I come up, it keeps getting bigger. There's 2.8, so it's higher than that, but it's lower than that. So it's on a one tail, it's between 0.01 and 0.005. Okay, or I would say perhaps that it's less than 0.01. And what that does is it simply confirms the rejection of the null hypothesis. And there you have 10-18.